Welcome to lesson 5.3, solving systems without graphing. We solve systems without graphing in one way by replacing a variable with an equivalent expression. Now, you may have just learned how to solve systems by graphing, so you're wondering, why am I learning another method? Well, it's because we need different methods because graphs don't always have clean solutions. Let me give you an example. If you were given the system y equals 1.8x plus 2 and y equals 0.7x plus 5, would you like to graph that by hand? And if you graphed it by hand, would it be easy for you to find that intersection point where it's a solution is presented, where that intersection is, where it's a value, xy value that can solve both equations? Most likely not. It would just be difficult to do. You would land in no man's land because it's decimal slope. Decimal slope is going to land you on a decimal intersection. So let me explain the substitution method to you. Here's the big idea. If you see y equals 2x plus 1, then wherever you see y, you can replace it with 2x plus 1. So if I see x plus y equals 10, well, I can replace that y with this. So I can replace it. So now we have x plus 2x plus 1 equals 10. Okay? That's the big idea here. That's the tool we're going to use again and again in this method. Now, this works so well because now we have like terms, and it would be a simple thing for me to solve the rest of this equation. Minus 1, this was a 10, and we get 9 equals 3x, and I would divide both sides by 3, and you get x equals 3. Okay, so that's the big idea. If you're given this and this, you can solve it. Let me give you a few examples of this in action, this big idea, this substitution method. So example 1 is going to be a clean substitution. We're going to have y equals 2x plus 1, and we're also going to have x plus y equals 7. Okay. Now, again, how do we approach this problem? And I'm going to work through a few examples, and then I'm going to work through 3 examples, and then I'm going to give you 4 problems. So you can pause now if you want, but there will be a chance for practice later. So this is a clean sub. So what that means is that we can plug in this value where it says y. Clean sub, so x plus 2x plus 1 equals 7. All right, I hope that's all making sense. So 3x plus 1 equals 7. We subtract 1 from both sides, and we get 3x equals 6. We divide by 3, and we find that x equals 2. All right, now that we found x equals 2, we plug it back in, right? We found the x value, so we plug that back into either one of these original equations. So we now have 2 plus y equals 7. Okay, We subtract 2 from both sides, and we get y equals 5. We have now found our solutions. It is the point 2 and 5, an ordered pair. This is the x and y value that satisfies both of these equations. And we can simply plug them back in to confirm it. Does 5 equal 2 times 2 plus 1, as this top equation demonstrates? Yes, it does. And does 2 plus 5 equal 7? It in fact does. So that is a correct answer. All right, so that's example 1. Now we're going to move on to a second example. This one's going to need a little bit more algebra, but ultimately it's the same method. So let's have a system y equals negative x plus 4 and 2x plus y equals 10. Okay. Now, when we see this example, there is a little more algebra to do. You have to take an extra step because it's not, well, it's just a little bit more algebra. It's not exactly the same. But ultimately, the big idea still applies. You're still given what y equals. You're still given 2x plus y. So you can plug this in. And that means we can have 2x plus negative x plus 4 equals 10. Okay, that's great. So let's combine like terms. This gives us x plus 4 equals 10 because we combined a negative x and 2x. Now we subtract 4 from both sides. Subtract 4 from both sides, and we get x equals 6. All right, now the moment we get that, we can plug it back in to either one of the first equations. Let's plug it into this one. So instead of negative x, it becomes negative 6. Negative 6 plus 4 equals negative 2. Y equals negative 2. Okay, if y equals negative 2, we can do 2x plus negative 2 equals 10. All right, so we can get rid of that plus sign. It's negative 10, so we add 2, and we get 2x equals 12, and we divide by 2, and we get x equals 6. All right, equals negative 2. Let's clean that up a little bit. Negative 6 plus 4 equals negative 2. That's our answer, and our answer down there. So we have y equals negative 2. We have x equals 6, and y equals negative 2. We need to put that in ordered pair form, so 6 and negative 2. That is our final answer. That is our point that satisfies both using the substitution method. Okay, let me give you one more example. Now this one's going to be the most challenging example so far, and that's because neither equation is solved. It's not in the form that you want it to be in, so to speak. But that should not by any means stop us from solving it. So 2x plus y equals 9. Let's erase that. And 2x plus y equals 9, and x minus y equals 1. Okay, so you'll notice that you don't see, y is not defined, nor is x defined. So what do? Well, you need to solve one of these equations for one of the variables. It looks like this is going to be the easiest one to solve for. So let's solve for y down here on this one. So x minus y equals 1. x minus y equals 1. So let's subtract x, and we get negative y equals negative x plus 1. Let's divide by negative 1. Divide every term on the left by negative 1. And we get y equals x minus 1. Okay, so wherever we see y, we can replace it with x minus 1. Okay, so we could say that x minus 1, we distribute this, equals 1. Okay. So then we have, wait a second. Okay, let's go back just a couple steps here. X minus y equals 1 minus x. Okay. So let's plug it in here. Okay. So we're plugging it back in. X minus x minus 1. X minus x minus 1. That doesn't look quite right. So what's going on here? 2x plus x minus 1 equals 9. That gives us 3x minus 1 equals 9. Add 1 to both sides, and 3x equals 10. And we divide by 3. And we're going to have our final answer, we'll put in red right here. Our x value, x equals 10 over 3. Okay. X equals 10 over 3. Let's plug the x value in. 10 over 3 minus y equals 1 minus 10 over 3 minus 10 over 3. This you could rewrite as 3 over 3. Negative y equals negative 7 over 3. Divide both sides by negative 1. And you would get y equals 7 third. Y equals 7 third. Okay. Good luck finding that answer through graphing. So that's the substitution method. Now it's time for some practice problems. Just remember that wherever you see y equals x, you can sub it in. And if you don't see that, you can manipulate the equation until you do. So now the next video will be on the elimination method, which is another very useful method. But now let's work through some practice problems. Okay, here we have a system. Go ahead and work through this one, and then I'll work through it. Okay, we're given a direct sub, so we can see that x plus 3x minus 2 will equal 6. We can go ahead and add 2 to both sides and combine like terms to get 4x equals 8. We'll divide both sides by 4, and we get x equals 4. Let's go ahead and write it in red. Over here, we have x equals 4. And now we can plug that 4 back in. So 4 plus y equals 6. We subtract 4 from both sides, and we get y equals 6. So our solution to this equation is 4 and 6. Let me erase this and put another one up for you. Okay, here is another problem. It's going to require a little more algebra. Go ahead and give it a try. All right, we're given what y equals, and we're given 2x plus y equals 8. Okay, let's sub that y value in. So we have 2x plus 5 minus x equals 8. All right, we can combine like terms. Well, we can subtract 5, and we can combine like terms to get x equals 3. All right, so we'll put that down here, 3. That's our x value. Now we can plug that in up here. So 2 times 3 plus y equals 8. We now have 6 plus y equals 8. We can subtract 6 from both sides, and we get y equals 8. So we can plug that in right there. And our solution is 3 and 8. All right, let me put one more up here. Okay. Here we are given one, and we're not given a defined y or x value, so you need to solve that. Okay. Let's see, how will we approach this one? We want to isolate a y on one side, so let's take the 3x plus y equals 7. Let's subtract 3x from both sides. We now have y equals 7 minus 3x. Okay. Well, now we know what the y value is. So let's take this as x minus 7 minus 3x equals 5. Okay. So we now have, this really is in parentheses, we need to distribute it. It's negative 7 plus 3x equals 5. We have an x leading. Okay. So now we can add 7 to both sides and combine like terms to get 4x equals 12. We're going to divide both sides by 4 and get x equals 3. So 3 is our x term. Now let's plug that 3 in. So 3 minus y equals 5. So we will subtract 3 from both sides, and we'll get negative y equals 2. We'll divide both sides by negative 1, and we get y equals negative 2. Negative 2. Let me just check that one. Okay, we're given, let's see, 3 and 2. Okay, 3 minus y equals 5. Y 2 divided by negative 1. Okay, that is correct. So our final answer, the points that will satisfy all of these, or both of these equations, is 3 and negative 2. So now my final question to you is more conceptual, but I just want to ask, and feel free to leave a comment, explain why you must sub back into the original equation. What's happening there? If you got something useful from this video, leave a like, comment, or subscribe. See you next time.